Are going to be talking about chain rule for derivatives. It's an extremely important topic in order to understand the idea of derivative and later on the idea of integral. Let's begin. The first thing we need to acknowledge is what is actually a chain rule. The chain rule states that the derivative of function from g from x is f prime from g from x times g prime from x. It might sound confusing, but in other words, the chain rule helps us differentiate composite functions. For example, sine from x squared is a composite function because it can be constructed as f from g from x for f from x equals sine from x and g from x equals x squared. Composite function. In order to understand the topic fully, we also need to be certain about what is a composite function. And it's actually a crucial element of the entire chain rule. It's a function that we can describe, in other words, as a function of a function. And the easiest way to understand it is by looking at an example. In this example, we have two functions, f from x equals 3x and g from x equals cosine x. A composite function of f and g is h from x. We can note it as h from x equals g from f from x, which is equal to h from x equals cosine from 3x. Therefore, we have a more complicated composite function of f and g, which is h from x. Now moving on to the topic of a derivative. What is actually a derivative? By definition, the derivative is a slope of a function. Derivatives are a measure of the rate of change, but they apply almost to any function. It is possible for this limit not to exist, so not every function has a derivative at every point. We say that a function that has a derivative at x equals a is differentiable at x equals a. For example, we can't make a derivative from a hyperbola at x equals 0 because it's impossible to divide by 0. Also, we mark the derivative of a function f from x by adding a prime, f prime from x. Here we can see a graph that showcases us how the chain rule formula could be proceeded in a graphic form. dy over dx equals f prime from gx times g prime x, which is exactly what I have been talking about for the last few minutes. Now, moving on to the formula. We are going to be analyzing the formula for the derivative of a composite function step by step. And the first things first, we need to remember that the chain rule tells us how to find the derivative of a composite function, and it is an entire purpose of the chain rule and why are we learning it. Step 1. We need to identify the chain rule. The function must be a composite function, which means one function is nested over the other. In other words, we need to be able to sort of split up one more complicated function into two simpler ones. Step 2. We need to identify the inner function and the outer function. So which one is nested over which? Step 3. Finding the derivative of the outer function, leaving the inner function. That's a very crucial moment because we need to do everything at the right order. Step 4. Finding the derivative of an inner function. And after we do that, we can multiply the results from step 4 and step 5. Finally, after all of these steps, the final one is simplifying the chain rule derivative. Now, let's look at some examples. Solving those will help us understand it all better. The first example. Let's consider functions g from x equals natural logarithm from x and h from x equals sine x. We want to find the derivative of a composite function of these two. Firstly, we need to define the composite function. Our f from x is equal to g from h from x. Therefore, f from x equals natural logarithm from sine x. We can clearly see there's an inner function, sine x, and the outer function, natural logarithm. In order to find the dx, we need to apply the chain rule, since f from x is composite. Sine x is the inner function, and natural logarithm from x is the outer, as I said before. Firstly, we need to evaluate the derivative from the outer one, so g prime for x equals 1 over sine x, and the derivative of the inner function h prime from x equals cosine x. Finally, f prime from x equals derivative of the outside function, leaving the inside function alone, times the derivative of the inside function equals 1 over sine x times cosine x. On simplifying, we get cosine x over sine x, which all of us know very well is equal to cotangent x. Let's take a look at the second example. This one will not be as fairly described as the first one, since most of these processes are done by yourselves now. To find the derivative of d over dx from sine to x, express sine to x equals f from g from x, where f from x equals sine from x and g from x equals 2x. Then, by the chain rule formula, we can evaluate that d over dx sine 2x equals cosine 2x times 2. So the result is 2 cosine 2x. Now moving on to the example 3, which has even less steps and even less explanation because, as I said before, it's best to do it on your own. We have the information that y equals sine from cosine from x squared, and it's the example that consists of double composite function because we have sine x, cosine x, and x squared. As we can see, the x squared is the most inner out of all of these functions, and sine from x is the most outer. Now, y prime from x equals cosine times cosine from x squared. Sine from x squared. 2x. We need to use the formula of finding the derivatives of a product word. After evaluating everything, we get a result, negative 2x sine x squared, cosine x squared. It might sound complicated, but once you write it all step by step, I'm sure everyone will get it right. So that's all for today. Thank you for your attention.